So I've described to you now how blockchain works, how the cryptography works, how the proof of work protocol works, and why it is a useful or an important component of blockchain technology. But I also want to bring to your attention some of the problems that arise and some of the challenges that you see in the community. In particular, the hype for blockchain technology has been around now for quite some time, for at least 3 years, I would say. And yet we have not really seen widespread adoption of that tool. We've not seen widespread adoption of payments in Bitcoin and the like. And so let's just talk about some of the challenges that exist. So for me personally, the major challenges for the community here are, of course, technological. So there's changes in technology that are needed. There are legal challenges, and there are economic functions that require very careful consideration. And all three of them need to be addressed for this to be successful. So let's talk quickly about the technological problems that are there. Number one is scalability. So the current throughput for Bitcoin is on the order of 5 transactions per second. The Visa network has something on the order of 5 to 10,000 transactions a second. So they have a vastly higher throughput. And if you really want to run an economy on a fully decentralized peer-to-peer network, 5 transactions per second is not going to cut it. Ethereum has slightly more, but we're only talking about 15 transactions per second. So even Ethereum, the more modern blockchain, does not have the same abilities. So that's a major problem and something that that the community has to address. Interoperability of blockchain is equally important. Now, there are obviously people are working on technological solutions there, but in order for blockchains to work, there need not be one for all, but there could be multiple ones, and there needs to be a way to have them interoperable. Then cybersecurity and privacy are major challenges from a technological perspective. You need to, people have a right to privacy. When they do Bitcoin transactions, they're visible. Same with Ethereum transactions. There is functionality. Basically, using the blockchain is really hard. Not in the sense of us sending money, with our phones to one another, but the cool part about the Ethereum network is that it essentially allows the decentralized execution of code. Now, the code is written in a language called Solidity, and it is not a particular user-friendly language. And in fact, if you want to be somebody who like a lawyer or, it's just somebody who's a businessman want to use the blockchain for something as simple as an escrow or as maybe an auction mechanism, you need to work really hard and you need to have a very solid understanding of Solidity in order to make this happen. There are smart contract features and smart contract validation and verification that needs to be worked on so that there's systems that make sure that smart contracts actually work the way they should. And then finally, you have, actually, this is something which comes rather unexpected is, finality in blockchains is not even guaranteed. There was a 51% attack on Bitcoin Cash recently, and that also puts a dent in the idea of that, the blockchain is 100% secure. Now, one of the biggest problems, in my opinion, is though, and this is a fundamental problem, is that of mining. So in 2009, mining was very simple. You basically had a computer chip and you just do it on a memory chip and you do it, right? Then came graphics cards, right? So you moved on from doing you moved on from CPUs to GPUs. And, these cards got better and faster. And then in 2012, people would, basically combine a few of these together and have the real mining rig. I mean, you can see how big that is. That is basically, something that you can put on a desk. Now, the Bitcoin became quite successful and people were kind of keen to do mining. And so they built bigger and bigger rigs. But as you can see, the cables here, this is something that you don't want to see. And usually the outcome, or oftentimes the outcome is this. So this is essentially a mining operation, which essentially just went up in flames. And there's huge security risks there. By now in 2015, 2017, this is a profession, right? So this is people spend vast amounts of money to run these mining operations. And if you look at 2018, so the one on the left, this is in Estonia, and people use high tech only to mine Bitcoins. So, and keep in mind that people put millions and millions of dollars into these operations with high developments in technology, only to have something of a throughput of 5 to 7 transactions per second. It's in some sense crazy. Most importantly, though, is that proof of work uses an unsustainable amount of energy. So just for 5 to 7 transactions per second, what we're currently looking at is that the energy consumption on a daily basis is the same as that of Austria, or twice that of Denmark, or 3 times that of Ireland, or 4 times that of a normal nuclear power station. This is the worldwide usage of it, and that's in January 2019. This is totally crazy. And in fact, and this is the important part about it, there's really no connection between the energy that you burn, which is a real resource, and the economic value that is being created. So this is clearly something which cannot go on. Then there is a problem that, we talked about this, the latency also is, for Bitcoin, is 10 to 60 minutes. You will not be able to pay your coffee by relying on the Bitcoin network and have to wait for 60 minutes in order for your coffee shop getting a confirmation of your payment. So now there are, of course, tweaks that people are already working on. So technology advances, and nobody in the right state of mind would use their Bitcoin to buy for a coffee. But there is, for instance, something called the Lightning Network, where the idea there is that you have a safe environment in which people can exchange Bitcoins rapidly, and they use the Bitcoin blockchain only at intermittent stages in order to have final settlement. So it creates a much greater amount of throughput. It creates the ability to do transact securely, though not at the same level as the blockchain itself. So there are technological innovations that can then help and allow micropayments and Internet of Things and so on and so forth to be run on a blockchain. But this is still very much work in development. Now, there are also some conceptual limitations, and we mustn't forget about them. So what you get with proof of work is, conceptually, it's only probabilistically true that any transaction has actually settled on the blockchain. Now, in practice, probability is 0, but it's not final, right? It's not like you have something in your hand. There are real questions that arise for these blockchains of an economic nature. So the minting that we currently have, so it means the creation of new coins, is according to a particular set schedule. But as a network grows, there are real monetary policy questions, right? So you don't want the act of holding a coin to be valuable in and by itself, because that makes it less useful as a means of transaction, so as a unit of transaction. All right. Anyway, so block size is a problem. There is, we have, we would like to have more information be put into the blocks, but as we make them too big, it's difficult to actually create decentralization to have the ability to transmit the information fast enough. So there are some conceptual limitations that are basically not easy to overcome. Other complications are the mining concentration. So the idea, of course, of Bitcoin, of Ethereum, is it is a decentralized network. Now, that would require that also the mining operations are decentralized. And here I have a graph which shows, essentially, this is from 2018, but it hasn't improved at all. It just looks at how many blocks are being created by different pools of miners. And you can see that in Bitcoin, it's 3/4 are determined by 1, 2, 3, 4, 5 mining pools. And in Ethereum, it is even less decentralized. So there, 5 mining pools account for something on the order of 75, 80% of the network. So that is not properly decentralized. So commonly, these miners can collude and they have great power over the workings of the network. They can force forks, they can, the governance, and this is an economic question, the governance depends on the will of the miners. All right. Now, let's quickly talk about the scalability. So, in Bitcoin, scalability is driven by the amount of data that can be put in the block. In Ethereum, it is essentially, the blocks technically have no limit, but there are gas limits. Now, these gas limits are endogenous over time, but there is a limit for how many computations can be done within a given block. Solutions exist. You have something like side channels. where basically two parties make the interactions, and only go to the final settlement to the blockchain when that's necessary. Another solution there is something called sharding, where basically you don't store all the information and you don't do all the processing in one spot. You basically shard them out and do parallel processing of transactions. So there are people are working on these two tools, and they're pretty cool and technologically advanced, but it is something which requires time to develop. Here's an example of a side channel. For instance, you have an electric vehicle and you have a power provider. You can put money in an escrow account. You can have the transactions are, money going back and forth between the charging station. And then at some point, every month or so, you do a final settlement on the blockchain. Whereas in between, you basically operate everything on a side channel in an auditable and secure environment. Now, the biggest problem, another idea is to change the protocol and go away from proof of work and do something which is not energy efficient, energy consuming. And the idea there is to use the proof of stake protocol. Now, what is the idea there? Well, the idea is actually quite simple. Is you basically put money down in something like an escrow, and then multiple people do this, and then among the people who are part of this protocol, who want to be stakers, who want to create blocks, one of them gets selected at random according to a certain mechanism, makes the proposal. The other people around that person receive the proposal and then vote on it. And if this person has done everything truthfully, then the person gets a reward. If the person has cheated, some of the reward is being taken away. And so if you do a random mechanism of people who are willing to put down the stake, you can imagine that you can create an environment where people would be willing to create new blocks and create new information. And it sounds really great and almost sounds too good to be true, because all of a sudden we don't need to expend energy anymore. But the real problem here is the so-called nothing at stake problem. So imagine that you have two blockchains, one short, one longer. What you want to have the ability to support the longest chain. Now the problem is, somebody who creates a new block could essentially append a new block both to P3 and to B6 at both of these points. So can you deal with this? Is this possible? So in proof of work, it's clear if you don't append it to the longest chain, you lose you lose your Coinbase reward. But for proof of stake, but you could easily continue appending anywhere and create an enormous number of different blockchains. Well, the answer to that is if you behave in such a manner, there would be a slashing condition. So you get punished for doing it. But it is not very easy to implement. There is another part, which is the so-called long-range attack, where you basically try to go very deep into the chain and create an alternate reality. I don't want to go there, but this is another concern that you have. So at the moment, there is not, in my opinion, a very convincing model that really makes it clear that proof of stake can work. And there's multiple things that need to be clarified there. Now, let me just quickly list a few of the projects that I think have a lot of promise and that will hopefully move the blockchain world ahead. So there's, of course, the proof of stake protocols that they're working on. In Ethereum, this is Casper. Bitcoin is the Lightning Network that allows microtransactions to work. Cardano is a dedicated proof of stake problem. I'm not going to go into what dedicated proof of stake is, but this is a very promising development. There is something called Algorand, which is awarded by a Turing Award winner at MIT, and it has a particular consensus algorithm which does not require, that overcomes many of the problems that proof of stake actually has. And then there's another algorithm that has been developed called Avalanche. It's the Avalanche protocols by IE3, so developed at, among other places, Cornell, and it's an iterative validation algorithm, which has a pretty cool feature in its functioning. And then they have also a staking condition there. Now, for people like us, we work in finance, and for us, we actually see that there are economic questions that the blockchain community also has to answer and has to think about. And I think one of the problems with some of the promising fundamental projects is that they actually have not thought about the economics as much as they should. So for instance, we need to figure out a way how we pay operators to maintain the chain going forward. There has to be a proper mechanism for that. You need to think of the system governance. So how do we manage changes? You need to think about how payment interactions work between one blockchain and the outside world or different blockchains. So if your salary gets paid in Canadian dollars and you want to interact in an economically meaningful manner on the Ethereum blockchain, you need to think about the exchange rate between the cryptocurrency and the fiat currency. It is of first order importance for the functioning of the blockchain. So in order to do that, you have to think about, essentially treat the Ethereum blockchain or any blockchain of that matter as an open economy. And then finally, you have to think of, we're going to spend an entire lecture on, token design and corporate finance of the functioning of blockchain items. I want to briefly mention that not everything is entirely based on this open community. There is also a lot of development is done on private blockchains by enterprises, and there is a nice connection between the two, which is the Ethereum Enterprise Core Alliance, where private blockchains are built essentially on top of Ethereum and use Ethereum as sort of like a backstop. So examples for that is Quorum, which has been developed by JP Morgan, and you may have heard about them issuing their own coin. There's the Aeon network, there's the Raiden network. So there's a lot of different initiatives that work and use the Ethereum blockchain as a backstop.